Eddie Jennings from EJSLLC.com. This video is another in my practice session series for the Red Hat Certified Specialist in Linux Diagnostics and Troubleshooting exam EX342. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed, to click the subscribe button and ring the bell when you do so you know when new content is available. Also, a reminder that these are my practice sessions before the exam. My exam is about 4 days away, so I'm going through all of the listed objectives by Red Hat, and I'm trying to either explain the objective or do a couple of exercises related to the objective. And at the end of the video, I'll do a little assessment, and hopefully at this point I will feel confident with whatever the objective is, and if not, I have a couple of days left to do a bit of brushing up. These should not be used as tutorials, nor should they be considered authoritative information. I try to have the information accurate because hopefully at this point in the preparation I have not learned something incorrectly, but since I am still learning and these aren't designed to be, explanations of stuff, it's just me reviewing some topics, these should not be used as tutorials or be considered authoritative in any way. I put these on the internet in hopes that those that are preparing for the exam might see some of the stuff I'm doing in my final practice sessions and be inspired to create some of their own examples and such to prepare. So we're going to start with the gather information to aid third-party investigation of issues, part of the objectives, and look at create kernel crash dumps. And I will say these two objectives of all of them are probably going to be my weakest. So I'll see how well I do with things on the exam. I'm going to try to talk through some stuff here just to test my own recall. But these have thankfully been things I don't deal with often in day-to-day life working with RHEL systems. I probably should do the knock on wood thing for that. We don't have stuff crashing all the time, or if there are crashes, it's kind of obvious what's going on. We're not having to dig into this that much. But these are good skills to have, and I can definitely see why they are included on the diagnostics and troubleshooting exam. So let me start a new session here, and we'll pick on good old server 1. So what this is talking about with the create kernel crash dumps, this is really talking about kdump, which I don't believe there's anything that actually needs to be installed for kdump for a RHEL system. I think it generally comes with it. And what kdump does, and if you're a master of this, and I get something wrong, by all means put it in the comments so those that are watching this later can get the correct information and not be led astray by my practice session, which is one of the reasons why I always say with these videos, what I say is not authoritative. It's just my understanding at the time of preparation. But anyway, basically what happens with kdump is it uses kexec to create a, for lack of a better phrase, like a temporary kernel that is watching the activity of the active kernel and thus is able to make a dump of what's in memory and the processes that are running and such. So that way, after the fact, you can try to get that file and analyze it. And if you're, a kernel developer and such, you can figure out, oh, so this is what broke in the kernel that has caused the crash, and you can make a fix and all that. From the system administrator's perspective, I think we may be able to glean some information out of this about, some particular process that might have caused the crash. And then we can look about maybe there's a configuration error or like a memory leak or something and deal with it there. I don't think on the exam they're expecting us to do, full on kernel debugging and fix stuff. And actually the objective itself, the realm is just gathering information, which that would be getting the crash dumps. One thing to keep in mind, and actually I want to look at my grub config. So etc grub, no, that's not what I want. I want etc default. I'm going to cat grub, see what it has here. Okay, so on the command line it's telling us crash kernel auto. This, I think by default, the kdump kernel will use 160 or so megabytes of RAM to run, and I think further by default, if you use crash kernel auto in your kernel options with the at boot time, you need to have a gig of RAM on the system for crash kernel auto to work. I'm not sure what's going to happen if I go less than that. I'm not going to test it with this because I'm fairly certain on the exam, whatever server that we're working with, we're not going to be able to change out hardware, whether it's a VM and changing its RAM allocation, and certainly, they're not going to give us a physical server to change hardware with to make that scenario happen. But just kind of good to know as far as general use of this in the real world, which of course is what Red Hat is trying to train us for. I do want to go into the configuration file for kdump and talk through a couple of things here. There are different ways of capturing the, or not capturing, there are different ways of storing the dumped information. What I imagine we'll probably be doing most of all will be either sending it maybe to an NFS share, or sending it via SSH over to some other server, or putting it into a file, which by default I think it goes into var crash, but we'll try to put that to the test. This raw, I think, will dump this to an actual block device. Path is where, by default it shows us there the var crash. This core collector thing, so from what I understand, this is really the thing that is doing the work when it is collecting the crash. And by default, just what's available here, it's using something called make dump file, which if you need to know some of the parameters for what you should put for a core collector if you're using make dump file, there's a man page for that, which is quite nice. These others I think are kind of self-explanatory. I haven't tested or played with them all. But the other one I wanted to mention, you can see here's what's happening by default, is this core collector SCP. This, if you were to, I'm not sure if these can coexist. They might be able to, not 100% sure of that. Nor am I sure if we can do like make dump file and SCP. I might experiment with that in this practice session just to see what happens. But if you do SCP, you can specify a user and an SSH key. We can then propagate that over to whatever system. And so what will happen at the time of the crash being gathered, it will SCP that over to another system, which could be particularly useful if this crash has happened and it's made the system, like there's no way to get back to it to look at the data. Assuming networking hasn't failed with this, I haven't tried this in a situation without networking, you might be able to get that data to this other system for you to do your analysis. So a couple of things that we're going to do with this. We are going to start and enable the kdump service. Oh, let's see, what time is it? 21:49. Yep. I think with all of these practice sessions, I've been doing them in the evening, and right around getting close to 10 p.m. for my local time is when my brain starts to turn off. And I start making mistakes. My last several exams, I've been taking them, the exam window starts at 10 in the morning, which is not super early, but enough for my brain to be awake to do my tasks. Anyway, so this should be going. Yep. And there is I think it's kdump CTL that can give us some information. Status should show that it's operational. And I think there are, when in doubt, -- help, right? Yep. All right. So we'll deal with propagate in a minute. We should be able to see with show mem how big. All right. So there's 256 megabytes of memory that's being used as the crash kernel. Let's see what estimate does. I actually haven't looked at that before. That's kind of interesting. All right, so I would imagine on the exam we're going to have to force a crash in order to make a crash dump or actually even says create kernel crash dump. So we're going to have to force a crash. And there are a couple of things that we could do with this. One is kind of the easy way. The others will be creating conditions for it. What I'm going to do is go into the proc file system. And I think what I want is under sys. Yeah, and what I'm going to do is find name panic. See what comes up here. Okay, so we're 0 for kernel panic. The reason why I'm looking for that is there. Here's what I wanted. Panic on some of these things here. Or is that what I was looking for? Non-maskable interrupt. Yeah, if there's some hardware, let me cat that. Panic on unrecovered NMI. There's some others that we're going to see if we can find. So non-maskable interrupts, I think these are, you can have hardware failure for this, or if you have like some type of iDRAC thing, you can send this to basically crash a system, or I'm not sure if it's necessarily intended to quote crash a system, but what you can do is, and I believe this is right, we can set that to 1, and we can do it like right now, put that in there, and it would just be valid till the next reboot, and that would then crash the kernel and create a crash dump for us. There are a couple of other, let me go back a level. There we go. There's more stuff. Hung task panic is another. Panic on OOM is one that I was thinking about. These right now are going to be 0. For example, if I do VM panic on OOM, but if we needed to set these, for example, let's say we have an objective that we want a crash dump to be taken if we get into the out of memory condition. So instead of OOMD trying to kill processes and such, we want to nope, just crash the system and we'll get the crash dump and figure out what's going on. We will set that to 1. So to do all this stuff and make it be persistent, we have to add these to the not system CTL, but the sysctl file. So what I'm going to do for that, and the reason why I'm copying this, let's see, sysctl.conf. Now there's some good man pages for this, but from what I have gathered, and I don't know if this is 100% true 100% of the time, but within the sys directory of the proc file system, basically anything after that, whatever it is, dot the file that's going to have the usually a Boolean setting for this is what you would have in our file here. So I'm going to tell that to be 1. And let's do kernel hung task panic. We're going to set that one to 1 as well. There's a couple more with that I want to set. There's other things with hung task panic. We can tell it the timeout in seconds. So let me cat that. 120. Let's say we'll let it hang for 240. Now there's a sysctl.d that we could dump some of this stuff into as well, which is probably the better way. All right. So we're going to load these changes. Oops, made a mistake there. Now it grabbed the others, but I made a mistake with forgot to do kernel dot. And so now if we were to check panic on OOM, that's going to be 1, and the others will be updated as well. That's how you would make those changes permanent. So one way to force the crash is to get us into those situations. Another way is to use sysrec, which from what I gather is like the magic key that you can, if your system is locked up, you can send it, and it's actually analogous to a print screen. You can send it commands, and some of which can be do memory dump, or in the case of what we're going to do is crash the system. You can get just that. So the sysrec, I know C is the command for crash. I think M is memory dump. There's others to do. We have to make sure that it's actually going to be enabled for us. So I'm going to see if I can remember exactly where it is. Otherwise, I will show you where I can find it in man documentation to help with that. So let me see if I can find it first. See, there's actually a sysrec here, but there's another. Yeah, that's not what I'm wanting. You know, let me go up a level and let me find. Okay, so it wasn't there. Sysrec trigger is, okay, that's what I'm going to send it to, I believe. But there was another thing with sysrec to enable it. Okay, it must be kernel sysrec and equals 1. So, but it had a value of 16. So let's do, and you would think, oh, let's man sysrec. No, the only place I've really found it is manning the proc file system and then searching for sysrec. And that will give us here. So, I see. So 16 is enable sync command, and that's one of the several commands that you can do for this. So we want to enable all the functions, so that's where 1 is. And then we're going to trigger a crash. So first, I guess I can do this not in a persistent way first. So we basically have it on now, and let's take a look at var crash. There's nothing in there, and we're going to send basically the C key, same as doing like print screen or sysrec. So we're going to send that to sysrec trigger, and that is going to basically kill my SSH session and cause the system to crash. Open up a new tab here. So we're not pinging yet. This you're not going to see on screen, but I'm going to go to my hypervisor to see if it's actually still powered on. Oh, and there goes ping. So yeah, it came back on. And then that should be broken pipe. Go to my VMs, see if it's finished booting yet. Again, this is not something you're seeing on the screen. I'm just doing this from my hypervisor, and yeah, it looks like it's back up. So let's go back into lab server 1, become root, and there is our crash dump. And it's showing the IP address and the date and time that it happened. Of course, since I did that from the system itself, the IP address is localhost. And this is some of the nifty stuff here. So let me clear my screen. I'm going to do less for this. So here's a dump of dmessage at the, I believe, the time that this occurred, this crash occurred. Now, this is probably not going to tell us much, but it is a nifty thing to see and use. We might be able to see if it shows. Maybe that's when it booted. Oh, dmessage will be, yeah, that makes sense. So this is when it basically has booted after the crash. Let's take a look at vmcore-dms.txt. Let's see what this shows us. All the way to the end here and kind of go backwards. Here is our sysrec. We triggered a crash. So what this might potentially show us is what happened, right before the crash, and then we can do some troubleshooting from there. Let's see if this is, no. There, or RPM QA grep kernel. We can install the devil or development kernel with this, and there's a command called crash that I believe can do some further analysis. Let me do a DNF. What provides crash? I doubt we are going to have to do analysis of a crash dump on the exam, especially since it explicitly says we're just collecting it. All right, so actually the name of it is crash. Yeah, so let's install this. Let's see what we can do with it. I'm curious to see what it pulls down with dependencies. All right, I'm going to say no, and the reason I'm going to look for something real quick. This will take a minute or so to run. What I'm looking for are the debug RPMs and the source RPMs. Because I'm going to enable those repositories. So I think there's some stuff I'm going to need to get from them. I may be wrong though, but let's see. We want just the base OS. Oh, that was the wrong one. I want this. If I can copy paste correctly. This will be source RPMs. And let's get the same thing for the app stream repos. There should be a source as well for that. Okay, so clear, subscription, manager, repos, enable. I can't remember if I have to do multiple enables or if I can just give it a list. Yeah, I do multiple enables. Okay, that should take just a minute. I think I did base OS source twice. Yeah, instead of getting the app stream. So let's try that again, this time with just the app stream. All right, and so let's install Crash, see if it grabs anything else now that we have those other repositories enabled. I don't think it will. I think it would have complained that we can't get the dependencies. Yeah. Let's take a look at Crash, because I think we have to give it the, to feed it a development kernel. Have any examples here? Of course not. We're probably not going to have to do this on the exam, but it's kind of a nifty thing. Yeah, this is it. All right, so we, in dump file form, have to give it the, well, maybe not. Maybe we don't need the debug kernel. I'm not going to spend any more time with that. I don't think I'll have to do it on the exam. I might review it on my own just for my own curiosity. The couple other things I did want to talk about, let's go back to the kdump.conf file. And that is this idea of the of message levels. This, go back to the make file here, and you can get more information from the actual make file man pages, or I have to go back to core collector here. And message level and well, let's just look at it from the actual man page. Basically, it shows you can alter the amount of stuff that is included with your dump file. And these are inverse of one another. I'm not exactly sure why. I'm sure there's people far brighter than me that write stuff for the kernel that would probably expand forever as to why. But for the dump level, that will show the different types of memory pages that are there. And basically we have what we want with our dump level, or depending on what's asked, one is basically include almost everything, and 31 is excluding everything. Then you can have for messages, go back to the beginning of that. For message level, it is the opposite. This is including stuff. So your message level 31 is including all of the things. Message level 1 and 0 are going to exclude, basically all of your messages. I believe I'm saying that right. Restrict outputs with specify message level. Yeah, things marked with X are printed, and then with the other one, the things marked with X are excluded. So that is something to take note of. And you can also do different compression. What I want to try to do now is configure this to use SCP. And what I'm curious is if I can have both core collector make dump file and SCP valid at the same time. I don't think that I can. One other thing to take note of is if you do this, then you're going to need to have like the key file and such already made. Otherwise, if you were to try to restart kdump, it's going to fail because some of this stuff is not here. So let me do lab server 2 egslab.com, and I'm actually not sure if I've set root to where it can SSH. So let me try that over here real quick. So usually SSH is me and then become root. Yeah. So let me set a password for root, and we'll need to do this for the propagate command, or we technically don't have to, but I'm going to for this. So let me sudo passwd root. All right, and actually while I'm there, I probably need to check sshd config, make sure root can log in. Yeah, it can log in. Okay. So that's what I want. Now I go back to my system here. I've made that that change in kdump.conf. I'm going to do kdump.ctl, and we are going to do the propagate command. And it's basically doing SSH copy ID to copy that, or it's generating the kdump key pair, and then it's using SSH copy ID to copy this over. All right, so now let's see if we can restart kdump. Yeah, I figured that would fail. Yeah, we can only have one core collector. So let me go back into that config, and we will comment that out. Restart. Taking its sweet time. Let's see what happens. Sometimes I get impatient with my services, but experience often tells me if a service is taking a long time to start, there was probably an issue. Not always true though. I probably should have done just start kdump. Okay, so it's, wasn't expecting to make that image there, which I wonder if that is because of the little external thing. So there's one other thing. Well, okay, stay focused. One thing at a time. So let's do our crash again and see if we can actually send the crash over to the other system. So let me go back to proc. I'm going to go ahead and add the sysrec to sysrec equals 1. And we want to load this configuration file. Okay, and let's trigger our crash and see what happens. So echo crash to proc sys, no, just proc sysrec trigger. Okay, so that crashes our system. Let's go over to lab server 2. We'll become root. Nothing in var crash yet. We'll let this finish crashing. All right, this is not looking good. All right, let's look back at etc kdump. Maybe I made a mistake. No, that unless it went into root somehow, and it did not. Var crash. There's nothing in here. Why did that not go there? It's almost like it didn't capture the crash at all. I mean, the sysrec worked because it obviously crashed the system. I lost my SSH connection. I got the key. No, I am not sure. I'm trying to think how I would even how I would troubleshoot this, like why it didn't send the crash. I doubt there's anything in var log messages. Well, let's just I know I don't have oh, there's kdump.log. Maybe that'll. This is about the right time. This isn't really telling me much of anything. You know, that's actually, like I said, these are the last couple of things that I'm the least strong with. So clearly I need to practice that a bit more to, you know, make it send over to our other server. I could continue trying to troubleshoot this. I know this video is getting long, so I think I'll take that back to another practice session on my own. But in theory, that should work to get that off the system. The other thing I was going to talk about is the thing with kdump is you have, you know, this is a service that's running. And so how do you capture what's happening during boot? And that's where early kdump comes in. I think that was a new thing for RHEL 8. And for that, you would have to basically make another boot entry. And you would have to make another init ramfs, which is using the drcut command. That I'm not going to demonstrate here. Mainly, I'm not super familiar with it, so that'll be another thing to try to get back to the front of my head. But I get the feeling we're probably not going to have to configure that. Of course, there's no way for me to know, and even if I did, I couldn't share because of NDAs and all that. But I have a feeling this objective is going to be something like, you know, configure your system to send the crash dump somewhere else and then crash the system so the dump is sent somewhere else. So As far as the exam itself, I'm not going to consider this the objective itself. I'm not going to consider this objective a complete fail, but I do need to do some practice with sending crash dumps to another system and get that to actually work, and maybe figure out some ways to troubleshoot it when it doesn't work, because clearly I'm surprised that this did not work here. But you know, the thing with these exams is cramming is not an effective thing, because these things aren't designed for memory, and at this point I'm not going to learn anything new. Conceptually, I understand what's going on here, so my practice is going to be more of, can I replicate some success? And if I can replicate some success, try to see what was different about that and failure. This isn't I've never done this before and I'm learning it for the first time. This is it didn't work this time kind of thing, so I'm not too terribly worried about it. Now, if I had no idea about these configs and things like that, then I would be far more worried. But it is something that between now and my exam on Thursday, I'll want to spend some time with. So if you found the video useful, make sure you do click like. I again want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed, to click the subscribe button. Thank you for taking the time to watch, and I'll see you the next time.